Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so after a long time, we have been not able to post videos due to some reasons, unavoidable circumstances. So sorry for that. So I hope we will be once again posting videos regularly. So please be with us, and also we are very grateful to all of you who are supporting our channel. So quickly moving on, today what we will be discussing, in the last class we have completed about electromagnetic induction. In this lecture we will be discussing about calorimetry, heat and calorimetry. Okay, so without wasting much time, let us quickly move on to our topic, which is heat and calorimetry. Okay, so note down the name of the chapter. This is a new chapter, heat and calorimetry. Okay, so this is a totally new topic, new chapter. I hope all of you are okay and fine, in good health. Exam is also near about, so I think all of you are studying to your full potent, and you will give 100% in the examinations and achieve your results or your goals. Okay, so today what we are basically going to discuss is the basic introduction about this chapter. So what do you mean by heat? First of all, if I just come to the point, what is heat? So the first thing that comes to your mind, I think, heat. What is this heat? The first thing that comes to your mind, heat is a form of energy. So it's a form of energy, like light, sound, all these are some forms of energy. Likewise, heat is also a form of energy. Now, what does this kind of energy do? This energy basically produces a sensation of hotness or coldness in our body. I think you must have all seen, nowadays the weather is very hot, isn't it? So actually it is the heat energy which is producing that sensation that it is very hot around. Okay, or in the winter timing, so when you feel very cold, it is the absence of heat. Basically, coldness means is the absence of heat that is making you feel cold. Okay, so heat is a form of energy which produces the sensation of hotness or coldness in our body. Okay, so it's a form of energy. Heat is a form of energy which produces the sensation of hotness or coldness in our body. So I think the concept of heat is clear by now. Okay, so definitely you cannot see heat, isn't it? It's a form of energy which you can feel. When you burn something, what happens? That process gives out heat. You feel hot, isn't it? So can you see heat? No. You can see anything burning, the flame you can see, but the heat you cannot see. Okay. So actually, if we cannot see heat, or if we cannot actually describe heat in a fixed way, then how can we get a idea of how much heat is there in your surroundings? For that, what we need to know the temperature of that surrounding. So in order to understand how much heat is present in your surroundings, or how much heat is present within a certain substance, you need to have an understanding of the temperature of that surrounding or that substance. So the next thing that we are going to discuss is temperature. So you have heard all these terms. Today we are just going through a brief recapitulation of these terms. So temperature. What is temperature? Can you remember what is temperature? I think you have also read about this term temperature. So this temperature is actually a physical quantity, isn't it? I think all of you have know there are 7 fundamental physical quantities, isn't it? And within those 7 fundamental physical quantities, temperature is one of the fundamental physical quantity which is having the SI unit of Kelvin, isn't it? Not degree centigrade or not degree Fahrenheit. SI unit is Kelvin, isn't it? Okay. So Kelvin is the SI unit of temperature. Now what is temperature? What is temperature? Now temperature is basically nothing but the degree of hotness or coldness. What? Temperature is the degree of hotness or coldness of a body. Okay. So temperature actually states the degree of hotness or coldness of a body. Temperature is nothing but the degree of hotness or coldness of the body, isn't it? So this is temperature. Okay, fine. So temperature actually helps us to understand how much heat is there in a body. Okay, fine. Now there are certain basic differences in between heat and temperature. Okay, heat is a form of energy, whereas temperature is a physical quantity which indicates how much heat is there. Then, okay, what is the SI unit of heat? I forgot to mention. What is the SI unit of heat? Now you all know that heat is a form of energy, and what is the SI unit of energy? It's joule, isn't it? Joule. But in case of heat energy, we also use some other units. We do not use always joule. You must have seen that in the food packets, biscuit packet or chips packet or chocolate packet, at the back of the packet the energy content of the food is given and it is mentioned in, I think you have all noticed in, it is kilocalorie. So rather using the unit joule for heat energy, in every case we also use calorie. So another unit of heat is calorie. Now where do you use this unit? Calorie, basically this unit is used for the heat content in food as well as for the heat content in fuels. When you burn fuel, what happens? You get heat energy, isn't it? So the amount of heat energy that is released while burning a fuel is measured in calorie. In fact, the quality of a fuel can be understood by its calorific value. Now you must be wondering what is calorific value. Calorific value is nothing but the amount of heat energy released in calorie when a 1 gram of a certain fuel is burned. Okay, so that is the calorific value. So calorific value means the amount of heat energy released in calorie when 1 gram of a certain substance is burned. Okay, so this is the units that we generally use with heat, and for temperature it is Kelvin, and the other units of temperature are degree centigrade or degree Fahrenheit, isn't it? Degree centigrade or degree Fahrenheit, these are also the commonly used units, but the SI unit is Kelvin. Okay, and what is the relation between Kelvin and degree centigrade and Fahrenheit? Now to relate centigrade and Fahrenheit, there is a formula: C by 5 equals to F minus 32 by 9. We are not discussing about the derivation of this relationship, rather we are just recapitulating it. So this is the relation between degree centigrade and Fahrenheit, and when we want to convert the temperature in Kelvin to degree centigrade, what do? We add 273 with the temperature in degree centigrade. So for converting degree centigrade in Kelvin, what do? Temperature in Kelvin is equals to temperature in degree centigrade plus 273. So remember these facts, these are actually helpful while solving some problems. Okay, so these are useful information that you need to have in your mind while solving problem. Okay, so this is the very basic concept of heat and temperature. Okay, now next thing, we are discussing mainly about the differences between heat and temperature. Now what is another, there is another difference. Do you know how can you measure temperature? Obviously yes, you need to have a thermometer, isn't it? So the device that is used to measure temperature is, what is this? It is thermometer. So just let me write it down here. Device that we use to measure temperature is thermometer. So the name of the device is thermometer, isn't it? Thermometer. Okay, and the device that we use to measure heat, what is it? Heat, do you know? This is new to you. We use a device called the calorimeter, and use the principles of calorimetry to determine the heat content of a body. Calorimeter, okay, calorimeter and principles of calorimetry. We will be discussing this about in details. Okay, so using calorimeter and the principles of calorimetry, we can actually determine the heat content of a body. Okay, so these are the very basic differences between heat and temperature. So the concepts I think are clear to all of you. Now quickly moving on, let us understand how can you get the heat content of a body. You cannot actually get the heat content of a body directly. There is a certain mathematical formula which we can apply to find the heat content of a body. So quickly moving on to the next topic, heat content of a body. If you have not noted down the facts, please pause the video, rewind a little bit and note down on the facts. These are very, very important facts you need to have in your mind while solving problem. Okay, so heat content of a body. Next topic is heat content of a body. How much heat is present in a body? How can we determine that? So for this some certain experimental analysis have been done, and from those experimental analysis we actually have drawn certain conclusions that can actually help us to measure the heat content of a body or the amount of heat present in a body. So what are those factors? Now briefly just coming to those factors. What are the factors on which the heat content of a body depends? First of all, just think of the fact, the more the temperature increase of a body, the more is the heat content of a body, isn't it? Just think how can we raise the temperature of a body? By supplying heat, isn't it? So the heat that we are supplying externally from an external source gets stored in that body as heat energy. So the first fact that we will be discussing is that more the temperature rise of a body, more is the heat content. So if we denote the heat content of a body by letter Q, okay, this heat content is first of all directly proportional to the temperature rise or temperature fall, you can also say. The temperature, if a certain body is say cooled, okay, cooled down, then you can certainly get the amount of heat that has been reduced in the body. So certainly this formula does not give the absolute value of heat, rather it can give you the increase or decrease in the heat content of the body. If we consider the reference or the heat content of the body initially to be at 0, then with that understanding you can say that the heat content of the body can be determined using this formula. Okay, so first of all, the heat content is directly proportional to the change in temperature. Secondly, it has been also been observed that the heat content is directly proportional to the mass of the body. Okay, just let me give you two examples. If you consider say two iron bars, one is of say 1 kg and the other is of say 5 kg. Now you actually heat both the iron bars in such a way that both the temperature changes for both the iron bars is from say 10 to 25 degrees centigrade. Okay, then actually you will see that the heat content in the 5 kg iron bar will be more than in the 1 kg iron bar. So heat content is also directly proportional to the mass. Now if you combine these two formulas, two factors rather, we get Q is proportional to M delta T, isn't it? Now, according to mathematical rules, what we know, if we want to remove the proportionality sign, or if we want to convert this relation into an equation, what we need to do, we need to multiply this by a constant, and that constant here is Q equals to C, small c, M delta T. What is this C? This C is called the specific heat capacity. This C is called the specific heat capacity of a body. This is a property of body. Specific heat capacity. Remember, this is a property of a body. Property of a body. Each individual substance have different specific heat capacities. Property of a body. Each individual bodies have different specific heat capacities. All bodies do not have the same specific heat capacity. Okay. So this is the specific heat capacity of body. Now, specific capacity can also be obtained by this formula. Then from this equation you can write C is equals to Q, total heat content, by M delta T. So how can you define specific capacity? Can you define specific capacity? Yes, obviously from this equation you can define. We can say that specific capacity is the amount of heat content in the body when the mass of the body is 1 kg and you have supplied heat to the body in such a way that the change in temperature is about, say, 1 Kelvin. Okay, you can also regard the change in temperature in degree centigrade or degree Fahrenheit, because change in temperature, if you consider 1 Kelvin temperature, it is not equal to 1 degree centigrade. Okay, rather 1 degree centigrade is equal to 274 Kelvin. But when I am saying the change in temperature, then the change in temperature is equal in all the units. If the change in temperature is 1 Kelvin, it can be also said that the change in temperature is 1 degree centigrade or 1 degree Fahrenheit. We will be discussing about this fact. We will be showing this, that mathematically it is correct to say that change or difference in temperature, which is 1 Kelvin, is equal to 1 degree centigrade. We will be showing this by mathematical calculation. Now, for let us, in the time being, just consider this definition of specific capacity. It is the amount of heat given, or the amount of heat content in a body if the mass of the body is 1 kg and the temperature rise or fall of the body is 1 degree centigrade or 1 Kelvin or 1 degree Fahrenheit, anything you can say. So that is specific heat capacity of a body. And we consider the unit of specific capacity. What is the unit? So Q has a unit of, say, if I consider the SI units, Q has a unit of joule, mass has a unit of kg, so kg inverse, and temperature has a unit of Kelvin, so Kelvin inverse. Okay, so joule per kg per Kelvin, this is the SI unit of specific heat capacity. Okay, so I think specific heat capacity concept is clear. Okay, fine. So to calculate the amount of heat content present in a body, you need to apply this formula, U equals to Cm delta T. Okay, fine. So I think this, up to this concept is clear. So for today's lecture, we will be stopping it right here. Time is not permitting us to discuss further. We will be continuing this chapter in the next lecture, and hopefully in the next lecture we will be discussing about principle of the calorimetry, as well as we will be doing some mathematical problems, numerical problems, which will be helpful for your understanding. So till then, let us bid goodbye. Okay, so all of you please take care and do study well, and if you have any inquiry, please do mention in your comment box. We will be happy to solve your inquiries and doubts. So thank you, and thank you for supporting us. Okay, till then, for the next video, goodbye.